Hi friends, welcome you all to Think Maths. We are in class 10 Maths, chapter 6, Triangles. In this session, we are going to discuss about the basic proportionality theorem. It is also known as Thales theorem because a Greek mathematician named Thales found the rule for the triangle. So it is also known as Thales theorem or BPT theorem or basic proportionality theorem. So what is theorem? It is theorem 6.1 in the book. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So, here what is given? We have to draw a line parallel to one side of a triangle. So, let me take the side BC. So, we have to draw a line parallel to BC. Okay. So, if we draw a line parallel to BC, we will get this line. This is the line parallel to BC. So, I name it as DE. Okay. So, DE is parallel to BC. So, this is what given. DE parallel to BC. Okay. Now, if a line is drawn parallel to one side of a triangle to intersect the other two sides. So, the other two sides are AB and AC. Okay. So, it intersects the other two sides in distinct points. So, the distinct points are E and E. Then, the other two sides are divided in the same ratio. So, how it is divided? AB is divided into AD and DB. And AC is divided into AE and EC. So, we have to get AD by DB equal to AE by EC. That is what we have to prove. So, we need some triangles. So, look at the denominator. We have DB and EC. So, DB is here. So, we should frame a triangle so that we can find out the area, and in that area DB will be present. So, I am going to join BE and CD. Okay. So, let us join this BE and CD. So, we will get the triangle BDE and DEC. So, when we find the area of triangle BDE, there BD will be present. Okay. In the same way, if you find the area of triangle DEC, EC will be present. So, if you divide some values, you will get the value of BD and EC. Okay. Now, another construction is in this triangle ADE. Okay. So, we need perpendicular to find out the area of triangle. So, we are going to draw perpendicular DM perpendicular to EE. So, DM perpendicular to AE. Okay. So, this is the perpendicular drawn DM perpendicular to AE. Okay. So, another perpendicular EN perpendicular to AD. So, this EN perpendicular to ED. Okay. So, this is perpendicular and this is N. So, we have constructed all the lines we need to prove the theorem. Okay. So, let me again say about the construction. We are going to construct two lines here, BE and CD. So, we need triangles BDE and DEC. So that when we find the area of the triangle, we will get BD and EC. Okay, so we are going to join BE and CD. Another construction is, in order to find the area, we need perpendicular. Okay, so we are going to draw perpendicular. Draw DM perpendicular to AE and another perpendicular EN perpendicular to AD. Okay, so these are the constructions we need to prove. Okay, now moving on to the next page for the proof. So these are the constructions we did. Now we are going to find the area of triangle. So area of triangle, first one is ADE. Okay, so there are two perpendiculars for this triangle, EN and DM. So first I am going to take the ratio for AD and DB. So I am going to consider the perpendicular EM. Okay. So first one is, this is ADE. So I am going to consider this N as the perpendicular for the triangle AD, first perpendicular. Okay. So now area of triangle is half into base into height. So half into, what is the base? Base is AD, and what is the height? Height is EM. Okay. So this is the area of the triangle ADE. So correspondingly, I am going to take the triangle BDE, because we have to prove AD by DB equal to AE by EC. So if I find out the area of triangle BDE and divide ADE by BDE, I will get AD by DB. So I am going to consider the triangle DBE. So area of triangle BDE. So which is also half into base into height. So half into, what is base here? Base is BD. BD or DB. So base is BD. And what is the height? Height, is it DE? No, it is not DE, because if you consider this triangle BDE, it is of the form this way. This is D and this is E and this is B. So this is the triangle. So suppose if we take the equilateral triangle, this will be the base and this will be the height. So this is height and this is base. If we take a right angle triangle, this will be the base, this will be the height. That is, height should be perpendicular to the base. But this is not perpendicular. So we have to construct a perpendicular this way. This is the perpendicular. Okay. So if we extend this, this perpendicular is here. It is EN. So for the triangle BDE, EN is the perpendicular. So EN is the height. Okay, understood? So this is 1 and this is 2. So I am going to divide 1 divided by 2. So in 9th standard you have studied area is denoted as AR. Okay. So AR of triangle. So we can say area of triangle ADE can be denoted in this way. So area of triangle ADE divided by area of triangle BDE, which is equal to half into AD into EN divided by half into BD into EN. So this half gets cancelled and this half gets cancelled. EN gets cancelled. So we get AD by BD. So BD can be written as DB. So AD by DB. So we got this value. So this is A. Next we are going to consider triangle ADE with the perpendicular DM. Okay, I will draw this here. So triangle ADE with the perpendicular DM. Okay, so now second part, area of triangle ADE. So if we consider this perpendicular DM, it is half BH. So half into, so the base is here AE and the height is DM. Okay, so this is the height which makes perpendicular, which makes 90 degree with the base AE. So DM is the height. So AE into DM. In the same way, its corresponding triangle is DEC. So we took ADE with the height DM. So we should take the triangle DEC because AE by EC. So we should get EC when dividing. So we should consider the triangle DEC. So area of triangle DEC. So which is half BH. So half into, what is base here? Base is EC. So EC into height. So here also the height is not ED because it doesn't make 90 degree with the base. So the 90 degree which makes with the base is DM. So in the same way as we said here, the height is DM which makes perpendicular with the base. Okay. So now height is DM. So this is 3 and this is 4. Now I am going to divide 3 divided by 4. We will get area of triangle ADE divided by area of triangle DEC equal to half into AE into DM divided by half into EC into DM. So half gets cancelled and DM gets cancelled. So it will be AE by EC. So this is B. Okay. So now we know one statement which we studied in 9th standard. That is, if there are two triangles with the same base. So this base is D. Now I am going to consider the triangle, two triangles which we framed here. That is triangle DEB and triangle DEC. Okay. So this triangle DBE and this triangle DEC. So if we consider this triangle, they have the same base. So this is the same base. Base is DE and between the same parallels. So between the same parallels. So who are the parallels? DE and BC. So DE is parallel to BC. So they are between the same parallels and have the same base. Base is DE. So they have the same base. BDE, DEC have the same base DE and they are between the same parallels DE and BC. If this is so, then their areas, the area DBE and DEC are equal. So we studied this in 9th standard. So area of triangle DEB will be equal to area of triangle DEC. So this is C. Okay. So here we have triangle BDE and triangle DEC. So this is nothing but BDE. So let me change it and write. So area of triangle BDE. Area of triangle BDE is equal to area of triangle DEC. So this denominator is same. Okay. So numerator is already same. If this denominator is same, then both will be in LHS. Both will be same. So if LHS is same, then RHS will automatically be equal. So from A, B and C. Okay. So from A, B and C, we will have AD by DB will be equal to AE by EC. Okay. This is what we have to prove. Okay. I hope you can understand this theorem. So we will see the converse of this, that is opposite. If the ratio is equal, then DE will be parallel to BC. That is the converse of basic proportionality theorem, which we can see in the next video. Okay. I hope you can understand this theorem. If you understand this theorem, just like, share and subscribe. Thank you.